Hello and welcome to today's episode of Rawkode Live. Before we get started, I want to thank my employer, Equinix Metal. They provide the time for me to invest into producing this material so that we can all learn together. If you want to try out the platform, please use the code Rawkode Live. This will give you $50 of credits. You can splurge that all in a few hours with some beefy hardware with 400 terabytes of RAM. 400 gigabytes of RAM, that would be a clever trick, and loads of CPUs, or you can use it more wisely. I prefer the former. We're going to take a look at OpenTelemetry today, so I'm going to invite my wonderful guests now. Hello, Amy Toby and Liz Fong-Jones. How are you both today?
Hello, I'm doing good.
Doing all right.
There we go. So let's start with you, Amy. I like alphabetical order lists. Can you just tell us who you are, who you work for, and then we'll move on to Liz, and then we'll get started with today's episode.
All right, I'm Amy Toby. I've been in SRE before it was called that, about 20 years now. I work at Equinix Metal with David, but I am a principal SRE in our software engineering group.
Okay, and Liz?
Hi, I'm Liz Fong-Jones. I'm a principal developer advocate at Honeycomb.io. We are a company that helps developers understand their software and how it's behaving in production. And I am a contributor to OpenTelemetry.
Which is great because today we're talking about OpenTelemetry. Could we maybe spend then the next, let's say, a couple of minutes and just kind of cover what OpenTelemetry is and what problem it's trying to solve?
Absolutely. So OpenTelemetry is a solution to the problem that previously there were a number of different ways that you could use to try to get your data from your application into platforms that could help you understand what was going on. So you can think of everything from New Relic to Datadog to Splunk to kind of more upstart modern tools like Honeycomb, right? Like all of these tools have their own kind of exporters, their own SDKs. And therefore, there is a high barrier to kind of adding one to try it out, to switching, to experimenting. And each of us who were on the vendor side had to re-implement the same kind of SDKs to collect trace data, to kind of to instrument frameworks. So we all decided basically back in 2019, and at the end of 2018, actually, we've been on this journey 2 years now, to merge all of our open source efforts and to combine them together into something called OpenTelemetry. So you may have heard of Open Tracing or Open Census. Those are kind of the two predecessor projects to OpenTelemetry. But OpenTelemetry's goal is to kind of unify all of this, that there's just one perspective on how to do it and not three.
Awesome. All right. So let's, we have a couple of comments. So we got Walid saying hello. Hello, Walid. Siam, thank you for joining us again. Now, the premise of this show is generally that we try to do very little up front. I like everything to happen in front of the viewer's eyes.
And I think that's really important because, like, Amy and I as principal engineers, we like to demonstrate to people that, hey, we as principal engineers sometimes struggle with syntax. We as principal engineers have our compilers not work, right? Like those are things that happen to everyone. We're not, perfect human beings just because we're principal engineers.
I got some inkling, so I did cheat a little bit and ran through some stuff. But I think David's starting with a blank slate. So hopefully we just eliminate the really tedious bits.
Well, I mean, I think we're kind of up the ante a little bit with this episode because not only are we starting from a mostly fresh slate, and I'll cover the mostly in a second, but we're all working with a repository that we have no experience with, essentially. I don't think any of us are particularly familiar with the project we're going to use. So let's cover the context then. This is I opened the wrong tab. This is supposed to be tinkerbell.org. Okay, the problem. Which is a provisioning platform for bare metal. Tinkerbell aims to solve the problem of I have a bare metal machine, I want to spin it up, get an operating system on it, and make it available for someone to use and provision their own software. Now, there's quite a lot involved with this. There are many moving parts. So we're going to focus on two aspects of it today, hopefully, which is, if I move over here and pull up the README, the Tink CLI and the Tink server. Now, these are the smallest kind of surfaces that we can work on. The Tink CLI gives us some commands that we can run that speaks to the Tink server over gRPC. Hopefully, all very easy for us to instrument with OpenTelemetry to a certain degree. But there's still a lot of complexity in this project as a whole. Now, we got very lucky and a colleague of Amy and I's, Jason, has worked on a tilt file, which I'm using today.
Tilt is amazing. I love it.
Yes. So this is the bit that is not merged into the main branch yet, but it is available for everyone to use. And the reason I did this up front is that there's a whole bunch of dependencies that happen in the background, lots of cache stuff that needs to be available in Docker images. And I didn't really want to make everyone sit and watch this for 20 minutes while it spun up. So I have done this up front. I do apologize. But we are in a position now where we can make changes to the CLI and the server components and the auto live reload. That is all I've done. And this will be available in the main branch soon. And to make sure it worked, I did what any senior developer would do and added a print to standard out called help me too. So if I
I'm trapped in a server factory.
And you can see, hopefully, if we've got this right, if I just remove the 2, then till, as amazing as it is, detects that change, rebuilds the image, redeploys it, and we can see the help me is now available here. So that is all we have done up front. What that means is we have a short feedback loop for making changes to this, which I'm hoping is enough for you two to be able to guide us through the process of adding OpenTelemetry to this project. Does that all sound good?
Great.
Sounds perfect. We're all about short feedback loops here at Honeycomb.
Awesome. Right. Well, let's start then with what is the first step, as someone working on a project has this great idea, I want to add OpenTelemetry to it. What is step one? What do we do here?
Step one would be, why don't we go through and look at a sample Go application, a sample Go server, that's a gRPC server, to understand how does OpenTelemetry instrumentation work. So if you go to github.com/open-telemetry/OpenTelemetry-go, without the dash this time. I know, we couldn't get OpenTelemetry, the GitHub name. Someone had squatted it. If you're out there and you hear that your organization owns OpenTelemetry, one word, we want to hear from you. Okay, and now go to example. And let's go pull up the gRPC server. So it's under basic.
Basic.
And look at main.go. I think this is it. No, this one doesn't have the gRPC. There's, I know where we moved that to. We moved that to OpenTelemetry Go contrib because it's, we didn't want to make everyone importing OpenTelemetry import all of gRPC. So now let's go to instrumentation gRPC. GitHub.
This one?
Yep. Yep, probably there. Yep, example. Perfect. And server. Okay, so let's look at what a sample application that's a gRPC application instrumented with OpenTelemetry looks like. So here's the standard, say hello, standard gRPC code for saying say hello. So what you'll notice is that we haven't actually changed the code very much for that. But what we have changed is that we've changed the instantiation of the gRPC server. So if you scroll down, you should see that there is, it's still all boilerplate, right there. That we've configured a stream interceptor that will automatically create trace spans anytime a request is received in the server. So that's what we're going to need to add to our gRPC instantiation inside of Tinkerbell.
Okay, so just so that I understand that correctly then, is the OpenTelemetry, when we add it to our Go package as a dependency, provides, especially the gRPC stuff, just provides hooks that we can just add to the server definition that does all the instrumentation for us. Like we don't have to manually go and instrument any of our gRPC functions or anything like that.
It adds the basic skeleton, right? You still have to add meat to the skeleton, but if you don't have a skeleton, right, like your body's going to fall apart, right? So you kind of have Halloween, I know. Day past Halloween, we can still be a little spooky, right? Like if you don't have a skeleton on the inside, like everything's going to fall apart, right? So either you can add that skeleton by hand, or you can have something helpful like OTel gRPC add the skeleton for you.
But
so the skeleton here is
it?
RPC calls coming in and leaving, right? So when you issue an RPC call, you want to have that instrumented. When you receive an RPC call, you want to have that instrumented as, hey, this is a trace span, this is unit of work. What's not done automatically for you is adding data on kind of some of the attributes of what's happening. For instance, things like what is the request, what server did you request, right? What size of server did you request? Or where's the server located, right? Like those are parameters that the generic framework cannot possibly know about. So you have to manually add them. Similarly, in the same way to how we kind of added the help, right? Like into the tilt console output, you can choose to add kind of logging messages or and attach them to trace spans. So those are all things that you can do, but you have to have a trace span that's already instantiated to add those attributes or log events to.
Okay, so now we have to do this over here. So let me just see. This is the server.main.go. Now this is it. Yeah, this is. So
if I had to guess, it's under a gRPC server.
gRPC. Ah, okay. So we should see something that looks like.
Yep, right there.
Right.
Set up gRPC. Right, gRPC new server.
Right. Okay. So do we need to then start, I'm assuming we have to add something to our go.mod that tells it to bring, or just add the import to the top of the file to tell it to bring in the OpenTelemetry code.
That's correct. So if you go back over to the example, you can see what the import is for OTel gRPC. Yep, perfect. That'll do it.
Yeah. Now I'm going to not save that because I'm pretty sure if I do, VS Code is going to remove it. It's thinking about it.
So helpful. So helpful. Okay, and then let's add the interceptor. Again, you can basically cut paste that.
I'll just do that. Okay, so we want to. Did I just copy all of this?
So you'll notice that when it says gRPC new server, the interceptors are passed as parameters to the new server, whereas you're programmatically constructing your list of server arguments in your application. So you'll copy the gRPC lines here, the stream interceptor and unary interceptor, but where you paste them is not going to be into gRPC new server because do you see like params ... So you need to add to that params list. Ah, yep.
So are we going to cause
you
a
already
conflict with
have
the
a
Prometheus?
I think it should coexist. I think you can have more than one interceptor.
Does the order matter? So this is going to go like be in the call stack, right? Like when a request comes in, gRPC is going to go through this list and call each of these interceptors and pass it some data. So we probably want it after that TLS setup thing or before. Like
if it works fine with Prometheus, it'll work fine here, right? Like the credentials are automatic, right? Or sorry, the credentials are done on init, right? The credentials are not per request. That should be fine.
Okay.
Okay. So now if you save this and uncomment it, in fact, VS Code is detected and added it already. Perfect. Okay. So that's great. But now, in addition, what we need to configure is we need to configure a exporter. We need to configure an exporter so that we can see where this output is going.
Oh. VS Code is
well, VS Code has gone a little rampant.
what?
Okay, we're good.
We're good?
Yeah.
I didn't touch it.
Okay, so first let's check tilt, make sure that it compiles as is.
It's currently building. Oh, we have a restarting field container. I think that was just that weird moment where we had that weird paste 3 times, and I think we're not.
It just backed up again. Your database schema is out of date.
Yeah, that's just a warning. We can ignore that one.
Yeah.
I've already ignored that one. Okay.
Interesting.
So we have a small problem.
Oops. Oh, team server.
I mean, that's going to show me the same that I got anyway, but I'll just double check.
Make the same change locally and see what it does.
Live debugging. Live debugging is excellent.
Well, nothing ever works the first time. I mean, that
No,
was-
of course not.
So I just remove it. We'll make sure that it goes back to a healthy state, which... I have insufficient CPU potential. No. Okay,
I think I've found one of our problems. Oh, it's serving now?
yeah, but I removed the gRPC hotel stuff.
Okay. So here's the other thing that we're missing. There was some common init stuff that we did in the OTel config in the example app that you have not yet done here. So if you go back to GitHub and you see where it says config.init, that is doing some boilerplate that we need to also add. So let's go look where that comes from. So that comes from it's common init code shared between the client and server. So yep, that may be able to take you directly there if GitHub will let you. Perfect. So this is the stuff that we also need to put in, except for this stuff is not specific to gRPC. So instead of putting it in the gRPC code, you should put this in your main function. So you can literally just sleep all of that init. And I would call it a function called OTel-init or something. That way it's nicely modular and put it in your main function.
Okay, so we go to our tank server main. We're going to drop in this init function. We're going to give it a slightly better name.
Yep.
And let's see if that saves. Okay, so maybe missing a few things.
Yep, you're probably missing every single one of those imports. And even if you aren't, even if OTel was not, or even if VS Code is not able to figure it out, it'll resolve the duplicates, so you'll be fine.
Yeah, I'm hoping when it saves, it'll just, cut
Yep,
that
there you go.
in.
Perfect. Yeah, it wasn't able to figure out SDK trace. So unfortunately, we have two packages named trace in OpenTelemetry. One of them is SDK trace, and the other one is API trace. So therefore, the name trace is not necessarily unambiguous. That's why we have SDK trace. So this is actually a great opportunity to talk about the difference between the API and the SDK in OTel. The API is what you use when you're instrumenting your code, right? So it lets you say, this is a span, this is a child span. Whereas the SDK is something that you configure once per process initialization. And the SDK is the thing that keeps track of where am I writing out data, right? What are my configuration options, right? So your application code doesn't need to worry about the SDK, except for in the one place where you're initializing your system and configuring it. And this means that libraries don't need to have a OpenTelemetry SDK. They just need to call the API.
So that's something I wanted to get you to talk a little about, Liz, was so if what you just said means we can start to lay in OpenTelemetry into this open source software, and, and it can lay dormant until somebody wants to turn it on or hook it up to Honeycomb or Lightstep or whatever.
That's correct.
That's cool.
Okay.
So does anyone know why my fatal is showing me?
Probably because your log package is not necessarily the same log package as we're expecting.
Just see what autocomplete tells you that logger can.
Oh, try logger.fatal.
Yeah.
You have a logger here, so let's use your logger.
But that's initialized. I guess we can pass it into the hotel in it, right? So.
Sure.
Yep.
I don't go very often. Does someone want to take over for this a little bit?
What file are we on?
I think Amy just volunteered.
Go ahead, Amy.
Which file is that?
Main.go.
Main.go. Yeah. So I guess we'd have to say log and then put in a type or.
You don't want log. That's going to cause a type collision.
Yeah, I'll grab it in just a second. Where's the interface? Logger. Pointer? Let's go pointer.
So while you're doing that, we did have a question.
Yep, that'll work.
A question, if we can tackle
Let's
that
do it
right
now.
now. So
Wait, is it logger.logger or is it log.logger? Pretty sure the package name is
logger is loaded. Let me fix it.
No, but the package name for log for the capital
What's
L logger is log. The package name is log.
Is it? Oh, I see. You're right.
We have a question saying if you have the Prometheus interceptors not enough, can it feed OpenTelemetry? Yes and no. Prometheus can feed its metrics into the OpenTelemetry collector to produce metrics. But this brings us to an excellent occasion to talk about the difference between a metric and a trace. A metric is a pre-aggregated point of data, right? Like it's like a gauge that's like, amount of CPU used or, amount of disk space used. Or it's a counter, like number of requests received. Whereas tracing is a lot more granular. So the Prometheus exporter, by definition, is not capable of producing that fine-grained data about the execution of every request. It can tell you how many requests you got, but like not how each request executed. So Prometheus usage is not incompatible with OpenTelemetry, right? Like you can feed Prometheus metrics into the OTel collector onto your metrics platform of choice. It's just that, you would rather, part of why we're going through this exercise is to get that higher granularity data.
Excellent. And I think Amy's code has now got the OTel in it happy. So I'm assuming we can, after our logger here, let's just remove the help me. We don't need that verification anymore. Is that we can just pass in logger.
Yep. I think that should do it.
Oh, I think you want... I don't know if it needs to be a pointer, but it'll do for now.
Well, it's not yelling at us anymore, so I'm not going to complain. Okay, so that looks like VS Code is happy, which is usually a good indicator. I'm happy when it's happy. So
what does Tilt think?
Let's pop over to Tilt and...
Tilt's always so critical.
We have a restart and failed container.
Did it just build?
So it's currently in this orange state. Yeah. So it might. Oh, let's wait. Was it?
Hey?
Okay, that might be it. Let's see.
So what's it complaining about?
It's saying no config file found, but that's info level. Do we have the pod logs? Do the pod logs tell us that there's like some kind of a crash or something?
Okay, let's take a look at that. So we can do, let's get pods. And let's grab the most recent one. Now I think that should match with what we get there. So we can try a describe and see if there's any other information. Yeah, it looks like it is just crashing. There is a warning.
Only we had some logs and metrics, this would be like so easy.
So we're not really getting anything useful. Now, if we take out it does. Well, if we take out the gRPC stuff, it does work. So I'm trying to work out.
It does with the build it out there. Okay.
So we were able to run OTel init, but not the gRPC interceptor. Can we try that to verify?
Yeah, we can try that. So
let's take out the gRPC interceptors. Oops, you commented out one too many lines. Yep, there we go. Okay, so let's try that to see whether we're at least able to initialize the OTel boilerplate.
Yep, it's green. It's healthy.
Interesting. Okay, so there's something about the interceptor that is not happy. So let's try the theory that maybe trying to have two different interceptors is not working. So let's comment out that and then comment this and see whether that works. I clearly don't know enough about gRPC interceptors. This is a research thing for me to learn about more later.
It's green. I think it works.
Did it recompile already?
Yeah.
Okay, so the answer is you cannot have more than one interceptor. gRPC will crash the server without an error message if you have more than one interceptor. Okay, great. So now let's fire up the CLI and let's establish a connection.
Okay, so I cheated and made a small just file that hits the server. So that is called a hardware list. So we should have something somewhere.
Okay, great. Let's find out whether we got a gRPC. Let's find out whether we got a gRPC call recorded to our terminal. So let's go over to the tilt file. Yep. Aha! Yes, we did.
Yay!
Okay, can we cover that then? So we're not actually writing that trace anywhere. So by default, the interceptor just drops that into standard out.
The interceptor does not, but the boilerplate, if you go back to the boilerplate in the
Yeah, main.
In main.go, what you'll see is that it's configured to write to it's configured to write to standard out. We can change that. We can send this output to Honeycomb instead. Amy, do you have a Honeycomb API key?
I do.
Okay, why don't you research? Why don't you go find the Honeycomb API key in the background?
I just got it. I'll send it to David so that he can try not to put it on the screen.
Yeah, that's all right. I can make that work.
I'll Slack it to you in the background.
Okay, so what are the first steps then to sending this to Honeycomb?
Okay. So again, we like to walk through the journey as if we were a user. So I happen to know this, but let's go ahead to GitHub Honeycomb bio OpenTelemetry exporter go.
I don't currently have admin, so that is a API key I found. So if we accidentally expose it, we're going to have to go bother people to clean it up. So
you can create a new API key.
I can?
Just create a new write-only API key, and then it's fine if it appears on stream. Okay. Yep. So just slurp that up.
I must be a team owner to create and edit API keys.
Okay. Why don't I sneak?
Let me just give me a second. I might be able to get us one real quick. I know people. Although he's offline, so.
All right, I'm just going to start copying and pasting code and see what happens. So
excellent. That's how things are done these days.
Yeah, I'm okay with that bit.
Yep, it's completely normal for principal engineers to do.
You copy paste it, and then you kind of hammer on it for a while, make it look okay. And
does this code go in our hotel init then, and not in the gRPC stuff? So.
Yep.
I'm assuming we maybe replace this part here. Let's mock this out for now.
Yep. Similarly, your data set.
Yep.
Don't turn on with debug enabled. We already have whatchamacallit, standard output. So we don't also need this. And it's a handy demonstration.
Okay, but I do need the bracket.
What's your team name? Is it Equinix?
Yeah.
Great.
Okay, so now I need to understand what that honeycomb is. So I'm just going to copy this URL and hope that magically does it. And paste this and call this honeycomb.
Yep.
I also.
No, it's /honeycomb. It's /honeycomb.
Right, okay.
We took care of that for you.
Yeah. Go dependencies have always confused me. I try my best. But...
Okay. Finding an owner, sudoing in as them.
He's actually poking at it right now too.
Oh.
So.
Okay. Great. In that case, I will leave sudo mode. Okay, and you want to change your data set to be a descriptive data set like open source Tinkerbell or similar. Yep, or like dev Tinkerbell maybe, since we're using this for dev right now. In a production environment, you want to change this to be configurable with a environment variable or similar. And our service name is Tinkerbell.
But would we want to include things like the environment name and stuff in that, or would that just be the app, and then we would use other dimensions for like?
You probably want to have one data set per environment, so you would want to programmatically construct your data set name.
Okay, can we kind of just break down some of these terms then, for me that's not familiar? So when we say data set, based on the conversation that you two are having, is that like a table, a database, something that groups?
It's essentially a database, yes. It's a kind of unit of being able to look at your data, at least within Honeycomb. So this concept does not necessarily have to exist in OpenTelemetry, which is why it's specific to the exporter.
Okay, and the service name, should that reflect that this is the Tink server?
Yes.
Right, okay. So we have our dev Tinkerbell database. We're tagging these traces that they come from a service called Tink server.
Yep.
And we still have a little bit of red squiggles, so let me see if I can work that one out just now. So the import seems to be okay, but this is complaining. Okay, so the data set
Oh, it's because you already instantiated another exporter called stdout. So I would like change exporter there just above to say standard to say like, yeah. So this is like, yep. And then again there. And then now you want to pass another STD trace with syncer. Line 66, yep. And pass, in addition to passing the stdout exporter, you want to, yep.
With syncer, and then we pass in our honeycomb, right?
Yep, that's correct. There you go. So that should roughly do it, and now we just need that API key. And as long as it's configured to be a write-only API key, it's safe to expose it, relatively safe to expose it on stream, and you can just revoke it afterwards. Worst case, someone writes like 100 events into your Honeycomb data set. Whatever.
Okay, so the Honeycomb exporter doesn't seem to have a close. Can I just comment this out?
It should have a... Oh, that's out of data documentation. Let me see what that ought to be. I believe that might be... Let me check that 1 second. It does not have a close. It does have a shutdown.
Okay, shutdown. Okay, and I think this is what we actually grabbed from the Honeycomb doc. So I'm going to pull down the other one, which I think I just got an out-of-date reference to here.
Oh, yeah. Yep, so that needs to go down. Yep.
And
you want that error nil above. Because otherwise, if creating the Honeycomb exporter fails, you want to have it fail out before you...
Sorry, can you say that again?
The line 65 to 67, move that above the instantiation of the trace provider. Because otherwise, if the Honeycomb exporter instantiation fails, you want to know about it before you...
Yeah, you have it stubbed to underscore on 50.
that needs a context. Yep. Yep, background context is fine.
Why is it not?
You don't have it loaded yet.
Or no, it's context. Like context dot.
Okay.
Yep, there you go.
Phew.
Oh, there.
It's not complaining
All right.
anymore.
Do we have the API key?
Yeah, David has it. You can paste that one. I'm an
Did you
admin now,
send
so
it
I can clean it up too. Yeah, I slacked it to you.
Okay.
Do you want me to just paste it in?
I'll just move this over here. And this is a write-only one, so I can share it, or do you want me to...
It is not... It's fine for now. Yeah, I'll
If there is a
remove it.
problem with it, we'll forgive it on the back end. Don't worry about it.
Alright, so I've dropped it in, and I've closed that file, so we can't open that file anymore. And if we do, we'll just deprecate the key later, so it's okay.
Yeah. Okay, great. So now, let's go to tilt, and having hit the endpoint. So,
Okay.
yep. Okay, so we're serving. We've successfully instantiated a Honeycomb exporter. It hasn't failed. So let's call the endpoint. Ooh. Oh, try again, I think.
Yeah,
There we go.
Error. Okay.
Where's my email? I'm going to try to add David real quick to Honeycomb.
So if I understand what's just happened there, we've added the Honeycomb exporter to the gRPC plugin, and it's now writing the trace data whenever we hit the Tink server gRPC API and sending that to Honeycomb.
That is correct.
Okay.
Unfortunately, I am not yet seeing your data on the back end, so let's see whether there's any errors or anything. Ooh. That doesn't look good. That sounds like we have some kind of fatal error.
Oh, yep, here we go. So our is telling us that something went wrong.
Oh, your defer is bad.
Oh.
I see the problem. So
we
what
just
happened?
commented it out for now, right? Like, it's not the end of the world.
Yeah, you want to move that stuff into your shutdown sequence, right? The problem is that it deferred at the end of your main function, whereas your main, or like your, does that make sense? So So
Yeah, but the defer runs at the end of the function it's in.
Yeah.
And you want it on to run at the end of main instead.
Yep.
Okay. Do you want to move that to fair, and I'll just leave my screen away
look.
from it because we have the token.
Yeah.
So.
I mean, for now, let's do this. I mean, you don't have to run it.
You do not have to run it. However, if you have a graceful shutdown, right, the idea is you don't want to lose your traces that are in flight.
Okay, where are we at? We're in OTel init, so...
Yeah, you may need to make OTel init return the Honeycomb object or return like a shutdown hook.
I was just going to paste it in here for now. So root command execute. Right, that should be fine for now, right? It's not. Oh, okay, I see.
Yeah, okay, now I understand. Yes, because we put it in the, yeah, okay. Fun.
Oh, my key repeat still isn't working. What's the type on that anyway?
It should be a...
Come on, VS Code, tell me.
It's a honeycomb.exporter.
No,
Honeycomb.exporter.
So
what was the problem when we moved the defer line down? It sounds like it got a little bit more complicated.
Because the defer was wait. Oh right, dirt. There we go. That should do it.
So the defer was inside of our OTel init function, but the OTel init function returns control to the main function immediately.
Okay.
The defer needs to make sure that it happens as part of cleanup after the rest of main finishes. So we needed to hoist the close function out.
Okay.
So now we've done that. I think that should work.
All right. Well, our tank server
is running.
Yeah, sorry if I lead. We're not showing the codes just because that API token was there, but I will push this code to my fork with the API key removed, so you can see the OTel init function. Don't worry. Now the tank server says it was restarted 2 minutes ago. So have we definitely saved that file and triggered a rebuild, or is it just tilt? I
mean, I did a :w.
You may need to trigger like an innocuous change to some other file, or you can just press the rebuild
I'll just
button.
force a rebuild. We'll see what happens here. So let's give that a couple of seconds. It's now running. So if I run this again, and it's pretty consistently now
working.
It's
reliable.
Hey,
okay.
I see data.
We have data. Okay.
Yep, we have data.
David, I sent you an invite. Should I take you a second if you want to log in Honeycomb? It should be in your Equinix email.
Okay, no problem.
Let's look at some of these traces. So earlier, we were looking at the traces in like a text format, like not super informative. So the goal here of using a visual tool like Honeycomb, or if you want pure open source, Jaeger, etc., right? The beauty of this is you can use the same instrumentation with multiple different backends. Then you can see in a little bit more detail what's going on rather than just having the things printed out to standard out.
Okay, so while I'm just quickly signing up for the Honeycomb thing here, right now we're instrumenting the gRPC server.
Mm-hmm.
Now, if we wanted to track that trace from the CLI, is that something that would be just as trivial to kind of add?
Yes, that's essentially correct. So again, we're basically following the OTel gRPC example, except for you want to look at the client directory instead.
Okay. Well, this is Honeycomb. You should be able to see that now. Let me see if I can just zoom in a little bit. So how do I see this trace data?
Scroll down to the bottom. It'll show you like a list of recent traces. So you can just open one of them. And you may want to collapse the left sidebar so it's a little bit
Oh, there we go.
down at the bottom. There you go.
Ah,
So yeah, so you can see here that we have the name of the gRPC call being made. You can see how long it took. You can see how long it took in comparison to other traces of that same name or other spans of that same name. If you scroll down on the right-hand side by fields, you should be able to see a couple of other fields indicating, hey, I'm a tank server, my status code was 0, and so on and so forth. So as you can see, it doesn't have very many fields, right? It's only what gRPC was able to automatically infer. So that's where the thing that I mentioned about, providing additional information about the client or about the request being made could be helpful here.
Okay. So how would I add extra context to that trace?
Great. That's a wonderful question. So let's pull up the RPC handler.
Okay, so here. Is this what you meant? Sorry?
No, the RPC handler for that get all call.
Ah, right. Okay, gotcha. Okay, so we want to jump into the hardware. And it is this push call here is what we triggered, I believe. Oh no, we did a list, didn't we?
No, you did a list. All. There it is. Yep. Okay, interesting. You do have a database, it looks?
Yeah. Yes, this speaks to Postgres database.
It speaks to Postgres. Great. So one thing that we'll do, maybe if we have a little bit of extra time, I don't want to do the CLI instrumentation today. I don't think that's going to be as useful as for your viewers. I think that the interesting thing would be to instrument that's all handler, and then also, if we can, instrument the database calls underneath it so you can see out of the total length of time that this is taking, how much is in the database and how much is in your opcode. Okay, great. So if we pull up the documentation for OpenTelemetry, so if you go to, in your browser, to go.opentelemetry.io, and go to the OTel, which is the API documentation, and go to subdirectories API trace. API trace. Yep, there we go. Perfect. So now you can see all of the things that are valid to do. Now, the first thing that you want to do, remember that gRPC automatically set up for us the tracing of my request. So that means that what we have to do, we don't have to instantiate any new spans, but we have to find the span, the OTel span that was created for us. So for that, we need span from context. So let's go look at the Go documentation for span from context. That one. Perfect. Yep. So you want to call go.opentelemetry.io /OTel API trace. And you want API, and you want trace.span from context and run it on your current context that gRPC has passed you, and it will give you an OTel span object, which has been helpfully shoved in the context. So let's see what that might look like in action. So at the top of your function, where is your context object?
I'm assuming it might be on the server.
Yeah, it's probably...
Get workflow No, that won't be it, will it?
This is where my gRPC knowledge fades off a little bit.
I think server is... it was in... We were just looking at it. Let me find it again. Yeah, it's in gRPC server.go. And it does not have a context object. So where does that all get called?
Well,
I presume the...
No, we previously removed the Prometheus thing from this, and I do see Prometheus code here. So would that help us understand where the context is if we look at this Prometheus code, or is that
No, the Prometheus package may have its own way of passing the info. So normally, like I'm looking at some example code, and it looks like if you need a context, you should just make context the first the first method, the first thing that you take in your signature.
Yeah, that's what I was just looking the rest of the functions are doing, so I can add that.
Yep.
Right.
Okay, so we just add this context here and gRPC server.
CTX space context context dot.
Yeah.
Okay. Context.
Okay, so now you have your context. So at the very top of your function, before you do anything else, you probably want to get the tracer. So remember, it's trace from context. It's not a method of the Go context. It's a method of OTel trace.
Oh, the OTel one. Okay, all right.
Yep.
So OTel dot trace.
It should just be trace dot. Yep. Trace from context or span from context.
No, that's all I have access to.
Yeah, I think it's using the wrong trace.
Okay.
Just start typing span from context or yeah, there. Oh, I see. There's runtime trace. Oh, delete that. It picked up the wrong import. That's why.
Okay.
Okay. So in your imports, let's just do this now. In your imports at the top.
Okay.
So let's import go.opentelemetry.io /otel /API /trace. Great. Okay, now we have the correct trace. Hopefully it doesn't delete it.
I've not saved it, so.
Okay.
Good. Amy's typing. Let's see if we get. There we go.
Yay! Okay. Yep. Check the API docs. I think it may potentially error.
Yeah, I'm just pulling that back up. It should return
nope,
span.
it just returns span. Great.
Yeah.
Okay.
We just haven't used it.
So now we can add attributes. What are some useful properties of this that may be helpful? Let's add something saying the number of results. That seems like a useful thing to do.
Okay, so we have the.
So at the bottom.
Yep. And then we do hardware. We make a list. So right after that error, we can go.
Yep. So here, span set attribute, I believe.
Attributes.
Yep, set attributes. And this takes a OpenTelemetry key value pair list. So OpenTelemetry has it because Go is silly. OpenTelemetry has its own key value pair. Yep.
Is it?
I think it's just API. I think it's in the API package.
Oh, okay. Do we need to import that, or will it let us?
Yeah, you'll need to import it.
Just one level up from trace, just OTel /API.
It's /label.
Oh. Oop, somebody deleted me.
Yeah, I think just don't save the file and it should hopefully stay.
No, it's not even under API. It's just OTel /label.
Ah! I did it again.
Stick an underscore.
I know. It's the worst. It's the utter worst.
Alright, we'll remove the underscore once we've got some code in.
Oh, it's label.
Okay, I'll remove it. Okay, you should be good.
So I'm importing from label dot.
Yep, and then label.int. So capital I int. Yep, and then now you pass the name of the key, which is going to be probably like num results or something. People in Honeycomb usually standards upon either camel case or underscores. It doesn't really matter which you pick.
Right.
And then you want to pass the length of your list.
So we also had a comment from one of our colleagues, Manny, who said that we could have got the context from stream.context and the all method, rather than adding a new variable to the signature.
It's len, not link.
Derp. Do I need to deref that? It should be fine with a pointer, shouldn't it? Oh, that's not a list.
That's a proto.
Yeah. What am I counting then? So we do stream that send. Oh, it doesn't actually store them. It just streams them straight out of the database. So we'll just add a little counter.
Yep. So you may need to. Yep. Great. Cool. Okay, great. So now if you call it, you should start seeing results with you should start seeing in Honeycomb, you should start seeing, hey, there are 0 results, I guess, until you add hardware to the list.
Okay, well, the tank server seems happy now, so let's jump back over here. And it's not crashing, which is awesome.
Yep. Okay, so now let's go to Honeycomb and...
Oh, there it is.
Go to the Honeycomb homepage, it's easier. Upper left-hand corner. There. And let's go look at one of the most recent requests, which is a few seconds ago. Yep. So now you can see on that span that there are... Scroll down to the bottom of your list there. Yep. You should see... Ooh.
Did it not show?
We do not see here the new attribute that we added. Oh, is that code even actually called if there are no results?
Good call. Well, actually, yeah. Wait, no. Error get all. Oh, wait. It's calling a function, so that's sending a closure over count. So is it actually going to count? It's going to still count 0, so...
Should still count 0.
It should still be sending it, right? Because getAll takes that function and then calls it for each result.
Should we just confirm that we're actually in this? This is the function that's being called?
Yeah, that might be useful to do as well, because we don't know for sure.
Yeah, let me just see what else we have here. But I think that all is definitely, hopefully, is what we're calling. And
okay, well, I can tell you that the OpenTelemetry side is fine. So it's just a matter of, are we calling it appropriately? And also, I guess, are we using the correct context object? But I'm pretty sure...
use the one that Manny said, because we had a comment from our colleague who said
Yep.
we should be using equals stream.context. So maybe that's just the fix there.
Oh, yeah. Okay, let's try that.
Okay, so let's just rebuild that with till. It doesn't seem to notice the change in this file, so it might just need a wee tweak to the setup. And that should be healthy again. Yep.
All right, let's call it.
Couple of calls. Jump back over here. Homepage. Oh, wait, that's 2 minutes.
Nope, you want the one from a few seconds ago.
Yeah, this one here.
Yeah, that'll do.
Let's see it yet.
No.
Direct.
Hardware service / all. Yeah, it is calling hardware service / all. Not?
What,
are we in the correct file?
Just something silly at the top of
Yeah, you could add a logger there to make sure that it's actually calling this code.
Oh, like
Echo,
a span
hello.
dot, it's like span.log or?
I
was thinking
let's
about
just
sending
do a
like
regular
those-
log that doesn't depend upon the OTel
I see, I
subsystem.
see.
That way we know for sure.
Do we have a global logger handle or? No, you got to grab it. Okay, got it.
Do you normally wrap up your stream after an hour, like on the dot, or do you let it go long sometimes?
No. There's been some that have planned for an hour that have lasted 2.5 or 3. So like, as long as you both have time, I'm happy to.
Yeah, I have time. Let's keep going. Let's while we debug this, why don't we add some database instrumentation too, since we know that the automatic instrumentation of gRPC at least is working.
Okay.
So let's go to, once Amy is done here, we'll go to the OTel contrib repo and have a look at the documentation for You're using the standard database classes in Golang.
Let's see.
Why is it complaining about label now? We did use label, right?
Yeah, it's complaining now actually.
Oh.
So maybe that's our problem.
Maybe that's why, is that it never picked up our change because it never compiled.
But here's we're using it, so.
It says no package for import. Go OpenTelemetry.io.
Can I see your go.mod? Actually, I'll go look at it myself. What does your go mod say? Your go mod says... Where is your go mod? Wait, that's weird. Why am I not... I may need to refresh my share. I think it's a little confused.
See.
Version 0.13, yeah, that's correct. Huh.
Are you looking at a different one from me? Because I don't see it.
It's stopped complaining now, if that helps.
Oh.
I think
No.
VS Code might just be having a little bit of a problematic day. Yeah. But it's not complaining about label anymore. Let's see, did we add a logger? We did add a logger to this function, so I'm going to trigger a
Yep,
rebuild
let's
of
try it and see what happens.
tilt. And we'll see if we see, what was the log message? Called hardware all. Alright, so it's running.
All right, let's hit the endpoint.
And I do not see our message.
Called.
Interesting.
Message at the
Service
bottom?
slash all.
No. Okay.
So now we know
No.
we've been instrumenting the wrong function.
What the heck?
Alright,
would
what
it
else
be
do we
then?
have then? Let's see. So if we come to the command root, we've got the RPC servers here. I mean, it looks like we're definitely modifying the correct one. The RPC server is tank gRPC, hardware.go. I mean, I don't see how we've been getting that wrong.
Yeah, this seems very surprising.
So what can we do? Now, our tilt also stopped noticing changes, which I'm going to assume is maybe potentially related. So I'm just going to add a comment to this file. Yeah, it's not triggering.
Yeah, I think that's a little concerning because I'm curious whether Tilt is even building the right. Like, is Tilt even building the correct files, right?
But we are seeing the OTel stuff from the OTel in it. So
that's correct, but it broke a little while, right? Like, it broke a little while after that. So,
all right, let's tilt up again, just in case. So
all right. Do you need to tilt stop first or not?
I just killed it.
Okay,
so
great.
If I reload this here, we can see that it's now bringing everything back up. We'll need to wait till all of this goes green.
Okay, great. While we do that, why don't we go ahead and look up how to instrument databases? And let me
so you
tell
said
my coworkers that I'm missing stand-up because this is more important.
We're missing an all hands too, so.
You can watch the tape of all hands afterwards. It's fine.
I'm just going to poke around here and see what I can see then.
So what kind of keys are those, Liz?
This is the terrible keyboard that I'm getting rid of soon. I do not recommend this keyboard. It is a Rawkode keyboard, and it unfortunately has a tendency to have key presses duplicate, which pisses the heck out of me. So I actually have a set of cherry brums and on a keyboard coming soon from Shenzhen. Okay, so we want the SQL documentation.
I found this import,
Yep.
but I haven't found any documentation. But can I just browse to that?
You should be able to find. Oh, I think that is a temporarily missing feature gap. Actually, I'm not sure that we have the SQL stuff instrument, so
Well,
I will.
We can just go. The database classes are pretty straightforward. It's not a.
Oh, yeah.
Anything,
Let's demonstrate how to add new spans. Perfect. Let's do that then. Automatic instrumentation is fun, but let's do manual instrumentation.
So
Okay.
in our DB.
So I'm assuming I pulled back up the hardware stuff, and we're looking for the DB calls, right?
Yep.
Yeah, there's.
Where it says DB get all.
Yep. So let's pop over there. Oh,
Which
So
directory
where's
is
that
under?
instrumented?
hardware here, hopefully. Yep, there we go. So there's all.
Okay, so here it's like running a query, right, with the context, which is fine. But my question is, where is it? Instance.query. Where's the code for instance query?
Let's find it. Instance.
Like, what type is instance? Can we hook in a little bit lower
right,
down?
Okay. Yeah, right here. This what you wanted?
Yep, but this looks like it's in Go. This is in Go's library.
Oh, it is. Yeah, okay.
Okay.
So we have a TinkDB struct with an instance on it.
Oh, that's doable. That's doable. Okay, so if you have a TinkDB, that means that if someone runs query, right? Right. If someone is running a query on it, then they're going to call the internal methods, right? So we can create a span every time the query method is called on TinkDB, because TinkDB implements SQLDB, and that's what's being called, right?
Okay, that makes sense.
Oh,
Okay. So where is where?
I don't
well,
see it in here.
they're all kind of open coded, right? Like they're. If you go into the hardware.go,
Yeah, there's this here.
they're just open written queries. So
Right. No. I'm saying the query function. Where is the query function implemented on TinkDB? If we go back to TinkDB and search for
It's
query,
calling it
It's just-
directly
no,
on the instance
TinkDB
variable.
is a struct that just has a SQL pointer. And
Oh.
instance is just a SQL pointer, so it's calling the Golang package.
Oh, it's calling the Golang
script.
package underneath immediately. Ah.
Yeah.
So I guess naively we could start by instrumenting it directly here, but ideally that we should be adding another layer inside of TinkDB to proxy the query so the instrumentation can be in a single place. Is that
Yep,
correct?
that's correct. Although, like as I said, once we get the your feature request is noted to get SQLDB in auto instrumentation ported over. We have not yet done that from OpenTracing/OpenCensus, but we will. Okay, so let's see here. Where is our
assuming we want to
context?
wrap
The problem
this-
is we don't have a context object here, right? Like that's the thing that worries me.
Yeah.
We
Is
kind
this
of
doing
need
the
that
same
context.
thing? Some of them have it. Just that one call doesn't. Why does just get all not have it? But like we can just change it, right? Like
Yeah, we can change it.
I'm gonna change it in hardware to pass the context, and then
Oh
Yep,
yeah, all the other
perfect.
ones have it. Okay.
Yep. Yeah, let's make it always take the context.
So let me follow. Oh, we're in the same file now.
it was. Did he pass this by around his pointers or just?
Nope. Nope. It's always passed by value.
Okay, so there's context. It should be good now.
Okay, so we have a context.
Did I totally break the build?
I'm sure we'll find out.
It looks okay. We're good.
Nope. Build failed, expecting
Oh yeah.
N51.
Oh, why did it not change orange here? Never mind. Okay, yes, so it did fail.
Did I get something wrong in the context passing?
On line 51, gRPC server.
Jeez. What? Looks like we accidentally, one of us bumped a key here.
Yep, that would do it. Okay, back over to TinkDB. Oh, now we've got more interesting.
We cannot use DB as type. TinkDB does not implement.
Oh.
Wait, what?
Yeah, so we do have a VS Code that is showing us an error.
d.instance.query.
Yeah, see here we've got, it doesn't accept this DB here.
Ooh. Oh, I see. When it's building this. Oh, okay. Back in here. Let's do a quick diff on this file. I bet we accidentally deleted something. I'm going to try to do this quickly in VS Code. David, I'm thinking we should just look at a quick diff of what we've changed, all we've changed in gRPC server, and then we'll quickly see what happened.
I've got too much going on here.
That's fair.
Yeah, there we go.
Hey Liz, there's a question about how would we make sure logs events, did we already read that one? Are during this request are correlated with traces.
The log correlation? Yes, so instead of using your logger, what you want to use is something called a span event. So you can just call span.add span event and then pass your message. So it's just a change from using your standard logger to using a span event. And then it'll automatically make it a child of the trace. db.database. So db.
I think db comes through from in root.go, and it is passed in.
Well, I think this should be DB.
What's your type definition where database is defined?
Maybe it is db.instance, yeah. What does server take?
Oh, it's private.
You shouldn't have to change that. I think it's the interface definition for DB, right? Like, yeah. So
I don't get why it broke.
I understand why it broke because you added context, right? You added context to the function signature. There is some other interface definition, presumably for testability, where you need to make it take context now.
Oh, because it was passed in. Or did we
in all the other methods it was, but you need to can you search your code base for get all? Like search your code base for get all.
There we go.
Yep, there you go. It's right there.
Nice.
That should do it.
Missing return. Oh no, wait. Let's see. Is that it? No.
Force to recompile. But also look at main go line 74.
Go, yeah.
As you can see, a lot of the fiddly stuff is not actually a no-tell. It's just like...
Yeah, we kind of expected a little bit of this code to fight us a little bit.
A little bit of spaghetti, yeah. Propagators.
What's the return? Oh, Honeycomb exporter.
Oh. All right. Hey, now the auto build is working again, at least.
We're getting there. It's happy.
Back off restarting.
So I just made up what I added to here. Maybe we should just undo this a few times. It looks like maybe... This was the changes that you both made off screen. Is that right? Or have I made that up?
That's correct. That's correct. Right. Like, because we had to pass in the Honeycomb exporter to be able to...
You don't want to return star Honeycomb exporter.
Yeah, you want to return regular Honeycomb exporter.
It's in Tink server main.
What's the
we need to return this function signature needs to return a pointer, not a concrete Honeycomb exporter. So go to the function signature here.
I added it. We do need to return a pointer to the export.
Yep,
right.
That's exactly correct.
And then down here, we're going to go return. We have a Honeycomb.
Ampersand Honeycomb exporter, I bet.
Yeah, we'll need to delete that API key afterwards too.
Yep,
Nice.
I'll do that as soon as we hang
Easy
up.
enough.
Oh, what? That's just missing that.
Yeah.
What's it complaining about?
How are these things all getting like randomly overridden?
It's already a pointer.
Okay.
Yeah.
Because we're probably
typing over each other, I think. It's okay.
All right, let's see what happens now.
running stuff.
Let's see, can I... No, the server's not running.
If only we had tracing, this would be so much easier.
Back off, restarting failed container. Force a rebuild.
Yep. Yeah, so it's compiling, but it's just not running.
Did we accidentally revert the change with the interceptors? Is that what's happening here?
Very possibly.
gRPC.
Yep, it would be in
They're
gRPC.
still there.
Including commenting out the Prometheus.
But something did go weird with that code at one just a few minutes ago, so I don't remember what we did.
Yeah, the
It
Prometheus
is
stuff
Okay,
is
that's still commented
out.
out. Okay, that's good.
There was one more line in here. That's right. That set up that it did something I thought was important. I don't remember what it was. Can you do a diff on this section, real quick?
Which file? This one. Oh, the creds is missing.
Oh, yep, the creds are missing. That would do it. Oh my goodness.
Hey! That looks important.
Yeah, it looks important.
I have no idea how that line disappeared, but
Well,
VS Code.
the curly brace disappeared at some point too, so must be all these sharing and everything overlapping.
Yeah, okay. Grumble.
so it's
All right, let's rebuild and see what happens. And then we can get back to the yak we were shaving, which was instrumenting the database call.
we're still
Nope,
getting
still
the back
failing.
off. Yeah. Why?
Let's diff. Can we diff everything we've done so far? Curious what that global diff looks like.
All right, so that's just the tank file. Main.go added OpenTelemetry.
Yeah, that looks fine. Okay.
Yeah, that differs in the main, so that's okay.
Yep. That looks fine. That all looks okay.
Added the context, added context.
And the context, yep.
And that's go mode. That's going to be big.
Yep.
Oh, let's go back up here. So Prometheus gone, hotel in.
Yep.
Logger
Oh, you
equals
removed you removed a logger equals log line.
That might be important.
That looks important.
What?
Oh, wrong way. Okay, so
Oh yeah,
That was there before, right?
I think so.
so that's in the gRPC main, right? Okay.
Yeah.
Yeah, just probably right after that brace.
Okay.
That'll probably get the build going. I'm wondering why they chose that. Anyway.
Let's just keep blaming VS Code.
Okay.
All right, it's running.
All right, let's make sure that this works.
Yay!
Hey! I'm annoyed that it fails silently if you don't do that, you know? Like that really bugs me. But okay. Great. Back to where we were.
Our result count shows up now.
Oh, it does.
Yeah.
Okay, so the problem was that it never compiled after logger equals log disappeared. So
Yay!
none of our other changes were making it through. So now we can probably delete that extra log line because we...
Yeah, well, let's not delete anything until we
Okay.
get through this next step.
Okay,
Yeah,
so
yeah. Okay.
Let's go back
So-
to the manual spans on the DB class.
Let's go to create manual spans in the DB.
Okay. So, let's see, where is that function? No, that was in hardware, wasn't it? Under the DB. Okay, so
Yep.
this is where we want to add our span.
Yep. So first we need trace from context. Yep. Remember, it's trace dot span from
Trace.
context.
And CTF, okay.
Yep. And now we need to we need to instantiate a new span. So we're going to, if you look at the documentation for the trace API, go docs again. Yep. So look at the type methods on type span. Yep. So to answer the question about what people were saying earlier about trace logs, right? Like add event, right there, add event. That's where you would have added your contextual logs. But instead of adding event, what we're doing, sorry, is answering the previous question about how you add logs. Here, though, we need to create a new span. So there should be a.
I should read the docs instead
Yeah,
of guessing.
read
Okay.
the docs.
I will be right back.
Yeah, no problem.
Oh, why am I failing to remember how to do this?
So when we call trace span from context, that's returning a new span, is it not? Or if I misunderstood?
No,
that?
span over context returns our current span. I remembered the deal. We don't actually need to run span from we will need to run span from context later. Potentially, no, we don't. Sorry. The thing that we want is to get our trace provider, or trace.start. That's it. Trace.start. So something like, let me paste it over. Actually, I can directly edit this, can't
Yeah, go for it.
I? Where are we? We're in database.
Hardware.
Database hardware.go.
And database, yeah.
Great. Where are we?
Line
Get
156.
all. Yes, perfect. Okay, so we want something like this. So something like this. Yep, that should do it. And I hope it automatically inferred. No, it did not. So we need to fix this, or if it's not happy about this.
I think the VS Code web interface has some sort of operational transformation bug because I'm seeing lots of duplications. So I'm just
Oh
gonna
no!
I see it too, yeah.
I'm just
Oh,
going to
no.
clean this up. I think that is where we want to be. So I've saved that. Is
Yep.
that right? Yeah.
Yep. I'm going to close my browser then to prevent. Oh no, it did more of that. Okay, I'm going to close my browser so that it stops messing this up.
Yeah. I think it's okay. I think we're good now.
Okay, look at the top. Let's make sure my imports are correct. Oh, nope, that's bad too. And we need an API trace as well.
Okay, so API trace.
And I think it might be just /hotel/global, not API trace.
Okay. Hotel global and API trace.
I want to find out what feature that is so I can make sure I always have it turned off.
Yeah.
Delete stuff.
It cleans up unused imports. So you have to add this underscore at the start until you have code that you
It is API global, sorry.
And it is API global. Okay.
Okay. So
Cool.
now let's go ahead and add with the trace. Let's add in some attributes to the span. Oh, actually, we don't need the trace library, I think, because we got the span automatically. Okay. So what would be useful to remember from here? What do we need?
Length of the query, maybe the input parameters, like the hardware ID.
This is get all.
Oh, this
so
is get all.
Okay, so maybe there's just no useful info about the span to report. Great, perfect. Okay, let's soldier on and see whether we get the get all span now in Honeycomb.
Should we just add something random so we can see that coming through? And we can
No, this should make it come through. It'll create just a span named tinkdb.getAll, right?
Okay, I gotcha.
This is creating the child span. So
let's check tilt is still happy.
So it'll still get us like how long the query took, right?
yeah, it'll still get us how long the query took.
So it deployed 30 seconds ago. I can still hit hardware list. So now we want to go to Honeycomb, and we should see this getting a little bit more complicated, right? We should have multiple.
That is correct. Ooh, look, two colors.
Ta-da!
Aha! Huh, the database is only half of the time. That's cool.
Well, I guess there's nothing being returned, so we don't have any hardware.
Hey, you have some files ready to add some, right?
Yeah. Should we instrument add hardware first, or do you want to just run add hardware?
Let's just run. We're running a little short on time. Let's just insert some things into the database and now make it a little bit slower.
I mean, this is when I was looking through this code last night, this is way further than I thought we would get. So
honestly, VS Code slowed us down the most out of anything here.
Yeah.
The share thing is really cool, though. I hope they keep working on it.
Yeah, I hope they keep working on it. Okay.
So we've just got to run this command, and yep, that's the one. The hardware, what was it? Push fail. Hard.
I think it wanted. Oh, okay.
I know. Ta-da! Okay, so now we should be able to call hardware list.
Okay, so now let's see what that looks like in Honeycomb.
It looks the same.
Mine, it looks the same, and we should now see some attributes that are being set. Like we should be able to see the
result count 1. So we got a record.
Do we have a result? Oh, we do. Wait.
Yeah.
And the database is still the fastest part. So it's weird. Okay.
So that does beg the question, right? Like, why is it that why is it doing so much stuff in the 40 milliseconds before it actually talks to the database, right? This is right? Like, instrumentation for the sake of instrumentation is pointless, right? Like, the reason why we do this is to uncover performance things or things that are like, that's not doing what I expected it to, right? And then you dive in and debug. Cool. Well, I think this is probably a good place to leave off and probably wrap it up. Yeah.
Yeah, definitely. That was super valuable to me, and I'm hopeful to everyone else that was watching. I think Amy and I can have some fun adding instrumentation to this and try and work out where that 40 milliseconds is going. But that was awesome. Thank you both very much for joining me.
That was fun.
All right. Well,
Any
have a
audience
great
questions?
day. Oh yeah. If you have questions, you have a few minutes to get them in, and we'll try our best to tackle them.
I
See
didn't
if we
put my
missed
Twitter
anything.
handle
I think
in my name. Oh, so much
so.
for
We
my
got a
reach,
thank
know.
you. That was really great. Thank you, Jacob. Another thank you from Mike. Thank you, Mike. And we did answer the question earlier, didn't we? Yes, we did. I think we're great.
Great.
All right.
Awesome.
That was a lot
Thanks
easier.
for tuning in.
Not easier. That was a lot easier from the point of view of importing OpenTelemetry and getting started. And, the challenges we had were completely unrelated, which was frustrating, but we got there in the end. So thank you both for joining me. Have an absolutely great day. And that was a pleasure. Thanks.
Thanks, David.
Adios.